recording at the moment. So what I really wanted to talk about during this MicroObservatory Monday was to introduce you to some NASA resources that are related to YouthAstroNet programming, and help you be aware of them. And then I'll post those resources into the educator portal. Before I start that, I want to just ask if you guys have any particular questions, because the other thing I want to make sure, since you're actively implementing, I want to make sure that we answer your questions. So are there things that any of you are dealing with at the moment? Do you have questions about? Well, as I go over some resources, you might kind of be reminded, oh, I wondered how to do this. So feel free to interrupt with questions. Erica's monitoring the chat box. Mary, yeah, definitely practice some of these steps. And as I said, Harry on our team is actually working on a tutorial for doing this advanced adding images together RGB tutorial. So you can be on the lookout for that. Okay, so I had a list of NASA resources that I want to find at the moment. It's somewhere on my desktop here. Yeah. And one of the first ones, a lot of times your students are taking images of objects in space, and they might want to see what NASA images look like of those same objects in space. And a great site for doing that is this site called Astro Pics. It comes out of the group that runs NASA's Spitzer Infrared Observatory, but they collect NASA images from all the big satellite telescopes NASA flies, the Hubble telescope, the Chandra X-ray Observatory, the Spitzer Infrared Telescope. Those are all images in here among other telescopes. I notice Marion Astronomy Picture of the Day is also a great site. The one thing Astro Pics has, which is kind of nice, is if let's say I searched for the Crab Nebula, because that's a MicroObservatory target, and I put that in the search box and say search. It's searching now. So here's all the images that have come up for Crab Nebula, and you can see they're in multiple wavelengths. You can kind of see them all as a thumbnail pretty quickly, but when you go to an image, the nice thing about it is it gives you some information about that image and its wavelength. So you see here, it gives you multiple resolutions of that image. It tells you how far the image is away, how far that object is. So here, it's in tiny type on my screen, but it says 6,500 light years, kind of telling you, is it in our own galaxy? Is it in our solar neighborhood, or is it way beyond our galaxy? It lets you know what constellation that object is in the sky, so it helps orient you to where this thing is. And then down here, it gives you information about the wavelengths of light that made up this image. And you see it also has this nice little zoom window. So it has a lot of nice ways to understand the Crab Nebula. It gives you a little information about it as well. So I like Astro Pics because it's so, you get so many choices, and you can quickly get a lot of basic information about the object that kids might have observed. So that's one. And even if we look up, let's see, the moon, I'm not sure what's going to happen if I look up the moon. So let's find out. Okay, so it's giving me moons of Jupiter. A lot. This site is yeah. There's the moon. Okay, moons of Jupiter, and all of these other images probably have some mention of the moon in the description, which is why they come up in the search. So yeah, which moon exactly? I didn't specify, did I? That was right. Right. So the search gives me lots to go on. The next resource I wanted to make sure you knew about is a great resource for visualizations, and it's from NASA. It's the Goddard Visualization Studio, and I'm gonna click on that. The Goddard Scientific Visualization Studio, because of course the skills YouthAstroNet students are using are science visualization skills, and those skills also go not only into image processing but into video and describing, using pictures to understand objects. And this is a great site. Again, it has a nice search tool. So if I want to look up, I don't know, I'll look up the Crab Nebula here and see if there's anything. So let's say I'm doing a project on the Crab Nebula, and I search on that. It has both videos and images. So here we have Chandra X-ray Observatory celebrates 15th anniversary, and there's an image that includes a Chandra Crab Nebula along with other supernova remnants in that image. Let's see what else came up in my search. On this one, it might be better to go more general, it seems, because it, oh, here's a Chandra tour of the Crab Nebula, which is a movie. So that might be a great thing. I'm going to play that. I think I've shared my audio too with you. So let's see what happens. So here's...
The Crab Nebula is one of the brightest sources of high-energy radiation in the sky. Little wonder, it's the expanding remains of an exploded star, a supernova seen in 1054. Scientists have used virtually every telescope at their disposal, including NASA's Chandra X-ray Observatory, to
were you guys able to hear that after I muted us? Hopefully. Did I mute everyone? Yes. Okay. Good. Yeah. So here's a case where you could use the site for students to find, if you want to find visualizations about topics that you're studying. Let's see, my next resource is a website called NASA Wavelengths, and again, it's a searchable website. This one is more for, it has a lot of classroom activities developed by various NASA groups. But if you are studying multi-wavelength astronomy, which I think Mary said she was going to be studying soon, you find a whole list of resources. They tell you kind of in what situation they're appropriate, and you can see details about the resource. And you can also, the nice thing about this is you can, trying to think how this works. So if I view the resources of this multi-wavelength astronomy gallery. I think there's a way, yes, you can add it to a list. So you can create your own curated list of resources that you really want to make sure to get back to. So if I add that to my list, oh, I have to sign in. I think this one, oh, I'm going to have to remember my email. I'm not going to put you all through that. So remember my password. But you can make your own curated list. Mary, the second site, the visualization site, was the Goddard Visualization Studio. I'm going to post all these links into the educator portal right after this webinar, and so you'll have the whole list of links. And in fact, I'll bring them up here. Yeah. So I know this is hard for you to see because it's tiny on your screen probably, but I've gone through these first three: Astro Pics, the Science Visualization Studio from NASA, and NASA Wavelengths. The next couple of resources are, we may have talked about them before, and I just wanted to remind you because, again, I'm a fan of mixing physical models, kinesthetic models, and digital and computer imaging. So one of them is this activity. I think we have a different version of it on the portal called Kinesthetic Life Cycle of Stars, where students act out the stages of stellar evolution from star-forming nebulas like the Orion and Eagle Nebula to stars in the main part of their lives, to planetary nebula. As they die, they eject the outer layers of their envelope, and then the explosive deaths of high mass stars. And I don't know if you can see, I'll try to zoom in here on this image, but these are pictures of students at various stages. Here they are blowing apart, exploding, and in the beginning, here they are as bits of gas and dust coming closer together. So that's a great kinesthetic model. Another one, which we will post on the portal as well, is more solar system or exoplanet related, if kids are doing looking at planets. And this is a human orrery. And so here's a picture. It helps you set up ropes with little tape markers as the different orbits of planets. And the nice thing about this one is it really gives a model of the different times of orbits for different planets, so that each piece of tape on the circular rope represents 2 weeks of time. And so for Earth, there are 26 pieces of tape. For Mars, there's 50 pieces of tape. And it's nice when you have a student on each orbit, and as you clap out 2 weeks, 2 weeks, 2 weeks, they each take a step along their orbit and can see how planets that are closer to their sun orbit faster than planets that are farther away. So, of course, it's also true in galaxies. Stars that are closer to the center of the galaxy orbit the galaxy faster than stars that are further out. So it's useful in lots of different ways. So those are my kinesthetic resources of interest. And then a NASA after-school program guide was developed that uses some of our resources that you're familiar with and others. It's called After School Universe. So There's just a few extra activities. There's a curriculum manual that's downloadable, and then there's videos of these activities in action. So I'm showing that because there's some activities that are really relevant for YouthAstroNet programming, and let me highlight them in particular. So, so this modeling the universe, whoops, where are they? Where'd it go? I'm sorry to make you dizzy while I find the table of contents. This modeling the universe and cosmic survey activities were developed here at the Center for Astrophysics, but they're great introductions. They're great for helping students who are using our telescopes to think about where these objects are located in space and in time. And then there's, you can see there's activities about telescopes, about stars and their lives, about galaxies, and most of these are either kinesthetic or hands-on activities. So this is an example of a student's model of the universe here, using various arts and crafts materials. Okay, next site I want to share. Now I'm going to go on to some of these multi-wavelength observatories from NASA and things that they have to share. One resource I am quite fond of is on the website of the yet to be launched James Webb Space Telescope, which will be the follow-on to the Hubble. Some of you may have heard that this was supposed to be launched this year, and it was delayed to 2019, and at latest, it's probably delayed till 2020, which is upsetting news because it's going to do a lot of good science, and the benefit of it is to be up there at the same time as Hubble. And so this is 2 years that it won't be up there at the same time as Hubble. But the resource I have here is about the difference between optical and infrared images of the same object. So for example, if I click on starburst, you can see here there's a list of objects. And here's one that we're familiar with MicroObservatory, the Trifid Nebula. There's a nice, I hope if some of you have not done an RGB of the Trifid Nebula, you should try it because it's really nice. In MicroObservatory, it comes out blue and pink. But this slider lets you see the difference between the infrared telescope view of the Trifid Nebula and the optical. Infrared, optical. And one of the things you can really notice is how the dark dust lanes over here, these dark dust lanes that are obscuring the glowing gas, the dust itself actually does emit light, but it's infrared light, which this view and the MicroObservatory telescopes don't see. But the Spitzer infrared telescope, that dust, you can see those dust grains are actually glowing in infrared. They're dark in optical, but glowing in infrared. So that's kind of a neat thing. And that Eagle Nebula that we just, here it is. Actually, you can see, Mary, I hope you can see this. It looks a lot like the whoops, what just happened? It looks a lot like the MicroObservatory image we just added together. There's those pillars. Here's the infrared view where all those optical stars actually kind of disappear, but all the dust and the dust in this nebula starts to glow in infrared. And then let's see what happens in X-ray. I don't actually know. Let's find out. So this is interesting. In X-ray, these hot young stars over here are emitting lots of X-rays, but that nebula, all that dust, is not emitting much at all in X-rays. So this shows you how different telescopes that see different colors or different wavelengths of light show you different things about the objects you're looking at. And the nice thing about this site, if I go back to the home page, it has everyday objects too. So here's an optical view of a smoke-filled cellar. And if I give more infrared, if you use an infrared camera, a thermal camera, which is what actually a lot of firefighters use when they're in smoke-filled buildings, you can see that the warm people who are emitting infrared glow and that glowing warmth passes through the dust, which is the same thing that's happening in that Eagle Nebula. The glowing dust you see in infrared, even though it obscures things in optical. Okay, so that is a fun multi-wavelength resource. And an image processing resource from the Chandra X-ray Observatory, which is run, it's operated out of the Center for Astrophysics here in Cambridge. A lot of our colleagues work on the Chandra telescope. They have a few activities around how computers are used to colorize the universe. And of course, that's exactly what your students are doing when they use JS9. The computer, when they choose different color maps, when they add images together, when they use the sliders in the JS9 tool to set the high and low brightness limit or adjust the contrast, they are recoloring the universe by choosing different colors to represent different pixel values. And so this is an activity using Chandra pixel values. The Chandra telescope actually counts the number of photons that come into each pixel. And so here is a set of data that's 11 by 11 pixels. And students create their own color map, choosing a color for any pixel value less than 40, any pixel value between 40 and 80, any pixel value between 81 and 120, and so on. Then they color this to find a pattern. What's the form of this particular object in the sky? And actually, I have no idea until I would actually do it, right? The numbers are what actually come back from the telescope. It's true of MicroObservatory, and it's true of Hubble, and it's true of Chandra. The thing the telescope sends back is this array of numbers, and then the computer translates that back into an image by colorizing according to the numbers and the brightness of each spot on the image. So there's some background material, and I bet that's Cas A now that I see the background material. So that's a simplified version of this supernova remnant. And the nice thing about doing this activity is that some of you may have noticed already that in JS9, if I reload this, down at the bottom of the archived images list, we've actually put some NASA FITS images. We haven't labeled them very well yet. These are all Chandra X-ray telescope images, and these first three are of that this data here from the Chandra X-ray telescope. It's a supernova remnant called Cas-A. And so the students can learn about how pixels and pixel values translate into numbers with Chandra X-ray data in the same way they use MicroObservatory data. And then they can actually open up that Chandra data. And you'll see here it says Cas-A 0.5 kilo electron volts. That's what KeV is. 1.5 to 3 and 4 to 6. This is telling you low, medium, and high energy, or red, green, and blue. So again, there's that data. We can do log scaling, color it red, open the next one, do log scaling, color it green, do the next one, do log scaling, color that one blue, that's the high energy, and then RGB mode. I've noticed some students and some YouthAstroNet groups have already found this and done this, but this is the multi-wavelength, except that it's all X-rays, low, medium, and high energy X-rays of this supernova remnant. And you can see what I just came up with isn't quite as intense as this. I guess I'd have to do a little more work, but it has some of the same features. A supernova remnant, an exploded star, which students can model using the kinesthetic life cycle of stars activity. I have a couple more Chandra resources that I wanted to show you. In addition to the decoding starlight, those of you who emphasize, who want to emphasize actual coding, Chandra has a second activity related. That was kind of a pencil and paper version. They have a virtual lab where kids use pencil code, which is a little bit like Scratch. It's an online coding tool, and they manipulate images with it. I don't want to demonstrate it during, it would take too long here, but I wanted to call your attention to it if you wanted to explore that. Another, and again, I will post all these links on the educator portal under the, I think there's a forum about hands-on activities. I'll post it there. This activity, how to build a galaxy, for those of you, I know that some of our YouthAstroNet groups have invested in 3D printing and making 3D versions. And this activity here ends up having, let's see if I can find it here. It has the 3D files for printing out an asteroid, a black hole, a supernova remnant, a planetary nebula, the Eagle Nebula, Mars, the Moon, the Milky Way galaxy, and the idea in this activity, oh, it has more, the Sun, Saturn, so various objects in space, and then it has activities around, some of these objects are in the solar system, some of them are in the galaxy, and then galaxies exist outside of our own galaxy. So that's a way to connect 3D thinking about the shapes of these objects that students are getting 2D images of. And then finally, I wanted to highlight, unfortunately, we're past the Women's History Month, but I happen to have a bunch of activities related to women in science that I wanted to pass along. And one is a set of posters that you can either print out, or I think there's an order form online.
I think so.
That you can actually order these posters. As I have them here, activities. Connects. Well, it has some of the activities I just mentioned. It has profiles of women. Actually, these are our colleagues here at the CFA who are part of the Chandra X-ray Observatory scientific staff. And then each of these people highlighted are women in history who are associated with space science. Actually, some I think other topics too, math, technology, yeah. So that was one resource. Another is this poster from NASA about women of color at NASA, and it has a nice set of profiles of lots of different astronauts, engineers, mathematicians, and other scientists at NASA. And then I think that's the end of my list. So I will post all of these. As I said, I'll go into the educator portal and make sure I post them all in the where is that hands-on activity? There it is. Hands-on activities and other resources under curriculum and implementation materials. So I'll post them right there. And we hope that when you find resources that you really like to use as part of your YouthAstroNet program, and you think it fits really well with the use of the MicroObservatory telescopes, we hope that you'll share there as well. So, any questions? All right. Well, you guys know how to reach us. We are always happy to help answer any questions. Remember that you can plan an interactive Q&A with us, or with Erica will help find a scientist here at the CFA for a Q&A. You have lots of opportunities, and we hope that, question for Mary. Did these 3D print models need special software? So typically, when you get a 3D printer, the files that run the 3D printer, they have a particular format, and these files here, I can't remember what the file format is. I think it's .stl files are recognized by most 3D printers if you have that 3D print set up. So these files are set to, and you can see approximate print time for each of them. So a lot of printers, they're laying down this plastic material, and it can take an hour or an hour and a half to print a particular thing. Yeah, so you just need to use the software that comes with the printer, and it will understand these files. Yeah, great question. Okay, well, we love seeing what you guys are doing, and we'll look forward to seeing you and your students on the portal. So thanks, everyone. Thanks for all the fun. That's awesome. All right. That's the end of today's MicroObservatory Monday. Bye.